Hello everybody, I'm Seppo Vainio. I'm professor of developmental biology. I work in Oulu University, and I work in the faculty of biochemistry and molecular medicine in Finland. Actually, we had a rock band at that stage, so we were having a gig around Europe, and we actually loved Berlin, and Berlin was impacting on the SHADOWPLAY band actually. And then I was a great fan of David Bowie actually, that was also a fan of Berlin. So Berlin is very important in my memories. Think about TV, for instance. It's totally man-made. If you think about living organisms like frogs, so it's like a jumping and going around. So I was really captured by this miracle in a way, how it actually does this job, how it jumps around, what is life, what am I, and so forth. I think that our research can go and study these details of life in a way and understand much better our own being. I left Harvard actually to come to Oulu, to land of darkness, stars and moon, with the blue sky ideas, basically to try to help the people with the diabetic conditions, to use my skills actually for their benefit. After 20 years now, I've developed actually new ways to do biosensoring of the diabetic patients, and also developed the nanomechanistic kind of synthetic biome level theory. So we now use all these skills to actually help the people with the diabetic conditions based on our skills to target and engineer the kidney as an organ. So actually, the Western world has a major problem in kind of diabetes. We have millions and millions of people actually that encounter this disease. And so in 40% of these people actually, they develop kidney complications, which leads to complete failure. And these fellows and people really need complete survival via the dialysis. Our goal is to break the wall by printing and fabricating the whole kidney organ by 3D printing. Even before actually I was born, my father actually was a scientist and worked with my godfather actually with the problem of kidney development. Now ever since of this time, when I'm now an adult, so it's a kind of great opportunity. We have great opportunities in science to actually dissociate the cells, the organ to single cells, put it back together, engineer the organ, do 3D imaging. So we can build really organs like Lego blocks into putting them together. So basically now, printing an organ is not anymore a science fiction, but it's coming to a scientific fact and opportunity for us all. When I moved from Harvard University to Oulu University, I met Professor Kauko Kouvalainen. Kauko was the teacher of Carl Tryggvason. They studied congenital nephrotic syndrome of Finnish type. If a baby is born with that disease, that genetic condition, so the baby when it's born needs a new kidney. So Carl Tryggvason actually solved this gene behind this disease, this condition, and named that as nephrin. So now we can today go and correct the nephrin gene basically in these kind of babies and engineer kind of kidneys to rescue such CTNF patients. It is easy for us to impact also similarly the diabetic patients, preventing their lifelong need to be in dialysis. So even though actually a lot of studies have been done on diabetes type 1 and type 2, we still actually fail to understand what are the causalities that lead to that disease. So actually wake up every night and every morning to think about these things, how to actually use our skills, the organ engineering, to actually cure with these people that have the serious condition. My mother was an artist, and she respected very much the scientists, so she kept almost like gods. So that kind of gave me good grounds to go on with my career.